Good evening, everybody. I hope you are all doing well. Good evening. Can you hear me?
Good evening, Prof. Yeah, we can hear you.
Can hear you.
That's good. And you can also view the slide I'm sharing with you.
Yes, please.
Okay, that's fine. Can you see my mouse moving around on the slide? Can you view the mouse moving?
Yes.
Yes, yes.
Oh,
Yes.
that's good. That's good. All right. I believe it has not been easy of late. I can predict the challenges some of you might be going through, coming for lectures in the evenings, and some of you working in the struggle, learning and responding to assignments and exercises. I believe it has not been easy, but at the end of the day, it will worth it. So, well, so how are things going? Are
We
things
can't
going well?
we can't complain.
Oh, why
It's
can't
very
you
tedious.
complain? Why can't you complain?
Because we signed up for this.
We brought ourselves.
You brought yourself, is that not it?
Yes.
Okay. But it's better to do it this way than maybe go elsewhere. Then they don't probably take you through some of these hectic things
So by the end,
exam.
you have the same salary.
You also have the same salary, but maybe you have the better knowledge. But they said knowledge is power, is that not it? So,
So they can
everything is.
go to YouTube and learn.
Oh, I see. Then why are you here instead of going to YouTube and learn?
We need a certificate.
Anyway. But then sometimes employers get to know who has gone through a better education. That's why sometimes we on the interview panel, some people come from some places and then we feel that they have not learned a lot, and we don't take them because the feeling that, well, so far we lecturers, we know about every school. What others are offering elsewhere, we know them all. So when I'm on an interview panel, somebody is from some school and he comes and he's even having A's, you begin to be doubting whether it is true A or maybe it is something. So we know. So it's better you learn this way than most of the time, even the YouTube crowd, the person will not go there and learn anyway. Because we don't have the discipline to even go there and learn. Anyway, so since you brought yourself, then it's good enough for me to continue my lectures. But in reality, is it very tedious that is almost at the state of not being able to manage it?
Oh, it's not to that extent, but I think it's getting tougher and tougher.
Okay, it will be well soon. You only have 2 semesters, so 1 semester is almost gone. So it will be well.
We hope so.
Okay, yeah, it will be well. Having said so, today we are moving straight to look at transaction management. We've been able to cover all the fundamentals that we needed to know. And so from now, we'll be delving into the more advanced topics. So one of the concepts in database management systems is transaction. And this topic is very critical when we even write computer programs, and very critical to the understanding of managing databases. When you look at the objectives are quite many, but definitely we would not be able to cover all the details over here. Nevertheless, you can read on your own. Just as somebody suggested that we could even read this from the YouTube. Okay. The concept of transaction management comes about as a result of several queries in databases, or a set of queries in databases together may achieve a single task. And if it happens that certain number of or a set of statements are going to achieve a single task, then that number of statements should be looked at as atomic or as one statement, because still, though we have parallel computers, still the concept of computer executing statements sequentially still exists. Even though we have parallelism, that computer, some of the statements can be executed in parallel, there is still an embedded serial execution of or sequential execution of statements. And most computer programming are also such that if a statement one is not executed, because probably the output of statement one will be needed as an input to the next statement. So if it happens that a set of statements must be executed to have considered the work done or completed, and all of a sudden, due to maybe errors that may come out from software or even hardware or networks, midway down the execution of statements, such an error or an exception occurs, then the database will be left in inconsistent mode, meaning that certain intermediary results will have probably been saved. And then perhaps there are subsequent statements that are needed to make the statement or the task complete. So when it happens that way, then we will consider the database to remain in inconsistent mode. So there is a need to have a way that we don't leave databases in inconsistent mode. So when we come to issues on transaction management, there are three things that are provided through three mechanisms that are provided to handle situations that may occur, which I'm trying to describe. One of them is, in databases, there should be embedded, or there is an embedded transaction support. Then another issue is concurrency. In database environment, one of the key advantages that we mentioned some time ago is data sharing. Data sharing. That multiple users can access the same data item simultaneously, or so to speak, concurrently. So when it happens that several or a number of users are accessing the same data item at the same time, some probably just retrieving to view, others to make an update or maybe delete or edit or so on to that same data object, there should be a problem. If concurrency controls are not in place, there should be a problem, because as one is viewing, another one is updating. So they may end up having different views of that data item. Okay. The third option, or another facility or strategy to deal with transaction management is recovery services. That well, let's say error has occurred, partial, the system has performed some partial update or whatever to the database, and just about to leave the database in inconsistent state. There should be a facility to reverse what has already done and then bring the database to its original state. So we refer to that one as recovery services. So in database management system, these three models are there to take care of the situation I'm describing here: transaction support, concurrency control, and recovery services. These three concepts are interrelated, and as we go along, we will be discussing them into details. Okay. So we will take first the definition of a transaction. A transaction is an action or series of actions carried out by a single user or application program which reads and updates the contents of the database. So a transaction, as I said, will comprise even a set, just one statement or set of statements or series of actions that are supposed or are being performed on the database. This is carried out by a single user. But then another user may also be carrying out a similar transaction even on the same data item. So transactions, generally, we should see transactions are set of reads and update statements. Reads and update statements. Maybe some of you can tell me from what we have done so far, a read statement that we have in databases based on the SQL commands. Which of the SQL commands is a read statement? Anybody?
Select.
Okay, select. Okay, which statements are the update statements? Anybody? Which of the statements are regarded as update statements?
Insert or update.
Insert, update, and which one?
Delete.
Delete.
Yeah.
Delete, yes, delete. So anytime in actual fact, in technical terms, anytime we say update to a database, we are talking about insert, delete, and then the update itself. So these key four commands, that basic four commands that we have mentioned: select, delete, update, and so forth, we can put them together and then apply them to some tables or some data items to manipulate the data in the database table. All right. If all the commands are supposed to read, that means it's just merely fetching records to memory. If all of them are only reading, and then there are 100 or many users reading the same object, we are not going to have any problem because we are only reading. All of them will read the same data. But when it comes to a situation where some are reading and some are updating, then there's going to be a problem. So these are the situations that transaction tries to address, such that that problem that may occur may be controlled by some locking protocols, which we will also be discussing as we go along. Okay. Strictly speaking, a transaction is a logical unit of work. I always give this example that when you, let's say, using your phone to transfer money, let's say mobile money, and an account will be debited and another account will be credited. And these two actions are not performed with one SQL statement. One SQL statement might come first and say update or may delete, sorry, update certain account with something. Then the other one will also come and say credit, or the one is saying debit, another one will be saying credit. Assuming that the debit has taken effect, and all of a sudden, before the second part of the statement, if the debit has taken effect and then the credit is just on the next line going to take effect, and then maybe what do we call it, an exception occurs, maybe due to hardware failure or some application software failure, maybe on your phone or something, or network disconnection or something, then immediately the money has been deducted from your account, but the person you are sending it to will not have his account credited. So then problem. I don't know whether that has occurred to anybody before. You then see that, I think they have deducted it from my balance, but it has not been actually sent, and the credit has not gone to maybe your parent living in the countryside. Has anybody encountered such a thing before where one side goes through and the other side doesn't go through? Okay,
Yes.
nobody has. You've experienced it before.
Yes, but it was with buying call credits. They take
Yeah.
the money, but then you don't receive the call credits.
So what happens eventually?
So sometimes you'll be there and then they will re-credit it back to your account, maybe your Momo account.
Exactly.
Yes.
So there is a recovery situation to turn the thing back and then give it back to you sometime. It happens with, sometimes it happens with even ATM machine. You go and then you go and dial everything, and before you realize the money even doesn't come, the thing has been deducted. Okay, so the concept that we are learning should address or has addressed some of these things. I recall years back when we were using a flat file system, which we discussed the first day that we met. The even in the bank, the software was Bank Master. At the time it was a flat file system, and a flat file system hasn't got this kind of transaction management. So when we do credit, debit, credit, debit, credit, debit, then we'll reach a point then that some credit will go through. Oh, sorry, some debit will go through, then a credit will not go through. Then when it happens that way, because there is no mechanism in there to roll back automatically, then in the evening when this, what do we call it, the audit department are checking the transactions, then they say, hey, there is a credit, something, but then the corresponding debit is not there. Then they would take note of that, and you have to go and reverse that single transaction.
Then you
Before they before they post the new one. Sometimes they would even ask us, the computer people, to go and reverse something that has got only one leg of the transaction. So that was a big problem at the time. But due to the concept of transactions that have been embedded into databases, that problem is now a thing of the past. But if you, the what do we call the application developer, do not have better understanding of this, because some portions of this cannot be done by the database management system. So the application developer will have to consciously make use of transaction management such that one leg of a transaction should not be actually committed or saved until all of them are done as one unit or one logical unit of work. You should not accept a partial transaction. So that calls for the understanding of transaction management. Okay. Before I continue, should you have any question to ask? Okay. Okay. So now let's take this series of statements here, and then let us try to figure out something here. The whole topic we are discussing today bear three things in mind: that either we are reading or we are updating. That means the reading or we are writing. So let's bear in mind the read is a select. The write could be insert, update, or that, delete, and so forth. So read and write are key issues under this topic. The other key issue we should bear in mind is the what we call the operation, database operation. For instance, when you look at this one, we read staff number, but the staff number is X, and we read the data item salary. Now we multiply salary value by 1.1. Then we write. Okay, how do we interpret this? When we read this value, salary value, and that of staff number, which is X. Now, it reads these two. The read makes a copy of what has been read on the database, and the read will access the database and then put this value or this read into memory. Now, in memory, we multiply the salary by this, and then we keep the result also back in memory. At this point, this salary is not yet committed to disk. It's not committed to, or it's not saved on disk. It's just being held in a variable in memory. Now it is the write that actually now accesses the memory and writes the current value back to disk. So you will see that the database operations that we perform on the data items and so forth, like assignment and then increment and all those things, have nothing to do with writing to disk or accessing the database, but only the read and write has to do with directly with the database. So if, for instance, we end this statement here, salary equals to this by this. So far as we have not written back to disk, we don't expect that the value of salary will have changed. Okay, so if we understand this way, it will help us to really appreciate what we are coming to study today. Okay. So two database operations are the read and write. Then the the operations that happens in memory, we may call it non-database operation, because that one doesn't affect the database, which is salary is equal to salary times 1.1. Okay. Any question on this explanation? Okay. Another thing about transactions is that a transaction can complete successfully and save the data, or there can be an error or an exception and it will be aborted. Okay. When the transaction is aborted, we expect that you should roll back or undo all that has been done already, so that the database will get back to its original state, which we may say the database is reversed to its consistent mode. Now, let me just also explain this. I think some students are disturbing the class today. I will soon be taking note of those disturbing the class. Okay. Now, let me also explain something here. Now, if we read contents of database values from disk and we put it in memory, all the non-database operations that are performed are simply being performed in memory. But assuming that, let's say, the salary from the read, what's an average salary for masters holders today? Can somebody give me some value of, in the market, what's an average salary for masters holders?
15.
Anybody? Okay, 15. Okay. All right. So now, let's say the 15,000 has been read from here to memory. And then we are multiplying the 15 by 1.1. This operation happening over here, you will see that it has put the value of salary at this point in the inconsistent mode, because what will be on drive, which is the 15, will be different from what is in memory now, because you have multiplied 1.1 to it, and the new value of salary will have been in memory by now, but not yet written to disk. So the two values are not the same. What is in memory, what is on disk is different from what is in memory. Now, so far as we are executing statements or manipulating data items copied from disk, and we are doing this in memory, you will see that the database at the time, the value of it on disk is different from the value in memory. So assuming that as this non-database operation is happening over here, and then this value has been increased by 1.1, another user goes to read the salary, he would in fact be reading the 15,000, because at that point the program wouldn't know, or the database is not yet updated, so it will be 15,000. Meanwhile, the value actually in memory in another user's system manipulating it, the value of salary is different. So now, which one is correct one? The one on disk, the one being processed, they are not the same. So when situations of this happen, we expect that what is in memory here should go down to at the point where we will write it to disk. When we write it to disk, you see that the database is back to its consistent mode. And if somebody reads it, the person will be reading the current value now rather than this. So this can create a lot of confusion, because if one computer is processing and it's changing the value, not yet save it, and another person goes to read it, will read the original value, and then so forth. So let's bear that in mind. So for instance, if this non-database operation is being performed and an error occurs, so far as we have not even saved the data, we expect that it should roll everything back and give us the original state. Okay, having that one in mind, we can go back and we can go on to look at some few issues. This diagram shows us the flow of how transactions are done. So normally, in many databases, until recently, where transactions are embedded implicitly into statements, in many databases, the programmer will need to use a delimiter to tell the compiler that this segment of statements that we are coming to issue are atomic units. So you would use a delimiter to start it, another delimiter, or keywords to start it, another keyword to end it. So that block becomes a transaction on its own. So in some databases, you can use commands like begin transaction, but depending on the database in question. Then there is a commit. Let's say you want all the non-database operations that have been performed, we want to save it, then you use commit. Then if some error occurs or something, you will say roll back. So these are some of the keywords that are used. So if I want to issue two statements, one to debit, another one to credit, I'll put them in a block by starting begin transaction. Then I will write my two statements. One update, one maybe one credit, one debit. After that, then I will say commit. But I can also put in another statement that if some error or something occurs, roll back to original state. So these are few of the statements that we use, but based on the database, you will see the actual statement, because I know in some you will only say begin trans. And currently, even Oracle, the begin and commit are become implicit, that you don't need to say begin transaction and commit necessarily. Okay. But in general, we need to know which statements or which block of statement represents that single action or atomic statement by using keywords around it. Okay, having said so, maybe I've spoken for some time now. Perhaps somebody wants some clarification before we continue. Okay, Wilberforce.
Prof, looking at the previous queries, it looks as if the delete is not part of the right.
The
delete query, it's not part of, but the read is for select, and then you said that the write is for update or insert or delete, but then we have a separate query for the delete one.
Oh, which private you say previous studies, which previous studies?
No, the previous slide before the transaction.
Actually,
If you can
Actually, you will notice that how do we call it? The update. Anytime we say update, we are technically there is a statement that says update. But when we are discussing things of this nature and we say update, we are considering or write. When we say write, we are considering the update itself, the insert, and then the delete. Why do you think delete should not be part of write?
Prof, so because on the query, the delete was not part of the right. So
I
it
don't
means
know
that
which query. I don't know which query you are referring to. Which query are we
if so the query was like first you have to read the salary. I cannot see the
okay, in
the
this
slide.
in the notes, the slide. Okay, let's go back here. Over here. Is it over here?
Yes, I cannot see the slides. It is. I'm just seeing only the.
Yeah, it's here. It's
I
here.
would have showed you.
It is not on. Are you
So
talking about
go
today's
go
lecture or
over
maybe
here. So it
previous?
says it read this one, please.
What we are saying, you see, these statements over here are basically, so to speak, an example given. So in this particular example, what we are actually doing is update. This right is about update because it picks a particular staff number X and it multiply it by 1.1. So his writing is updating the previous salary by a new value. That's the right. So this particular one that we see over here, what is happening is an update. But then in order to give you a general idea about when we see right, what it will portray, that's why I was saying that the right may consist of update, delete, and even an insert. I don't know whether that answers the question. This particular one is only performing an update.
Yeah, I was thinking that maybe they would have used the update.
Because now from now you see that we somehow in this particular lesson we are not writing query statements directly by saying that select this or delete this and so on. But it's teaching us a concept that anytime we see read, he's talking about select. We can code this using SQL statements, but here we do not code them using SQL statements because we already understand. Well, we have understood query statements, so we are now just trying to explain how transactions work.
Okay.
When we
Okay.
go on and on and on, when we go on and on, you will see the query statements again representing this right and all this. But anytime we say read, select, we are fetching to memory. Right, we are talking about update, delete, and or the insert, so to
Insert.
speak.
Okay. All right. Thank you, Prof.
Okay, all right. Any other question on this? All right, so now we can, since we don't see anybody, we can continue. Okay, so having said all this, there are certain properties that a transaction must have. We've just talked about it, but what are the key properties? Normally in databases, when you hear something like ACID properties of a transaction, the ACID is an acronym meaning atomicity, consistency, and then isolation and durability. So when you have a transaction, these properties are in fact quite related. So let's take them and then see the properties of a transaction. atomicity, that is all or nothing property. What it really means is that set of statements you are talking about is the set of statements is regarded as indivisible unit, that all of them are performed as a whole or none of them is performed at all. Okay, so the part of the database management system that handles atomicity is the recovery subsystem. So what it does is, so far as the debit is done, but the credit is not done, it should be looked at as nothing is done, so that it will reverse everything to the original state. That is all or nothing. If it is not unable to perform all the statements, you shouldn't perform any, even though when it's getting to the end, before it realizes it cannot finish all the statements, it should pull everything back. Recovery system should bring everything back to original state. Some people develop database management and they have a lot of problems because they don't make use of these transactions. So you will see tomorrow they will say, oh, one side has gone through, but in the other side, it has been a problem most often. If you don't use transaction management properly, such a thing will happen, and correcting them is sometimes quite difficult. Quite difficult. For instance, if you write the program to do debit and credit, after that debit and credit is done, sometimes it needs to write what has happened to a log file, and then so that we can also log which timestamp and who did what and what. So in the process of trying to log into the log file, maybe something happened and it couldn't log what has happened into the log file, or it needs to update some balance table somewhere, and you couldn't do that one because of an exception that has occurred. Then the programmer could write a program, a transaction, and say that once it is unable to write or do the write into the balance table, even the debit and credit that has gone through, it should reverse it. If it doesn't reverse it, then you will see that maybe the balance table will be holding the same balance as the original, which is an error. So this is a concept of all or nothing. Another one is consistency. The transaction must transform the database from one consistent state to another consistent state. I explained that one to you, that when we read, and then we are performing non-database operations, you will see that we are changing the values of what we read, but it's not even affecting the database at that time. So at a certain point in time, we may now have to write the new value to go and replace or update or delete or whatever the previous value. When it happens like that, we say that you move the database from one consistent state to the other consistent state. So this one is a responsibility of the database management system, even the developer, to ensure that that has happened. Okay. Now the next one is isolation. You know, several people are accessing the same data object. Several users are accessing the same data object. And therefore, the isolation property requires that each user should not even be aware of the fact that some other person is also using or accessing the same object. So the transactions may execute independently. So if whatever each person is doing, maybe at the time somebody is multiplying salary by 1.1, somebody else is adding something to the same data object somewhere. Then another person is even deleting the object anyway. But each of these people or users doing this should not have the feeling that others are also doing that to it. So in other words, the partial effects of incomplete transaction should not be visible to another transaction. Okay. But that probably when you see this, you feel it's going to create problems. But mechanisms are there to ensure that though somebody is adding, somebody is multiplying, somebody is even deleting, mechanisms are put in place. And then the mechanisms are put in place in the database management systems. Specifically, the concurrency control subsystem takes care of that one to handle the isolation, that each person will be doing whatever he wants to be doing to the database object. But eventually, when they all update the database object, the database object should not be thrown into inconsistent mode. Okay, the last one is durability. The effect of a successful completed commit transactions are permanent and must not be lost because of subsequent failures. So now eventually, when the database, non-database operations are performed, even by different users, once the item has been saved, so to speak, committed, even if an error occurs later, it should not affect what has been saved already. What has been saved, permanently recorded. So even if you say roll back, no, it shouldn't affect anything that happens later on, should not affect what has been saved. So that is durability. Okay, having talked about these properties will guide us throughout all that we'll be doing under this topic. If you have any concern, question, or further clarification, you can let me know as we continue. Okay, so having said all this, let us now, these are the various components within the database architecture. I'm sure we saw this database architecture before, otherwise in chapter 2 or so, chapter 1. Okay, so you can read about this, the database, different models within the database management system that handles the recovery, the transaction, and then the what do you call it? That the transaction manager, the recovery and concurrency. These are the components that help us manage that. So their responsibilities are here, and the tasks that they perform are here. You can read about this. Okay, having said so, we will move to the next subtopic, which is concurrency control. You will observe that when we started, I told you about 3 things that are very critical when we are dealing with transactions. I mentioned the first one, which is the transaction support. Then you have concurrency control. Then you have recovery service. We've thrown some light into transaction support. Now we are coming to throw some light into the second one, concurrency control. Then later we will talk about the recovery services. What at all is this concurrency control? The process of managing simultaneous operations on the database without having them interfere with one another. Even in our discussion and interaction today, I mentioned quite a number of issues regarding concurrency. So the concurrency control now attempts to ensure that even though there are simultaneous operations on the same database or database item, the control ensures that each operation will not interfere with the other. So that is concurrency. If they interfere with the other, there will be a problem. Whilst one person is adding, another person is deleting, and so on. If they are operating, then this one will come and override the other person. So one will come and operate another person. Probably we'll need to sound this warning again. One thing I don't like is when I'm teaching and students leave their mic open and probably not even paying attention, but just log into the system and leave it somewhere. And noise and all these things are in it. It's one thing I don't like. I don't want to pin down anybody by taking note of who is doing that. But please, you are old enough. Let's ensure that we do the right thing. Okay, Samuel, your hand is up.
All right, Prof. I had a question regarding the isolation. So you gave an example where one person might be altering the same object, so deleting and then maybe changing some of the things. How does the system know which action to eventually keep? Because something like deletion and altering the object at the same time are two different actions.
Yeah, so that is actually the problem. If isolation, each operation is performed independently, and one user or one set of operations has knows nothing about what the other person is doing, so it becomes a problem. Just as you have a problem, I also have a problem. That is actually a problem. So eventually, which one should be kept? And then, because it appears somebody's own will override the other person's operation. So, and that is the reason why we are learning this topic. So eventually, as we go along, we'll come and look at the protocol. There is a protocol, blocking protocols, that automatically will handle each of them and ensure that at the end of the day, there will not be a problem. No one's this thing will override the other. So that is the work of the concurrency control. So when we get to looking at protocols that will handle that situation, we will understand it better how they do it in such a manner that eventually the database will not be thrown into inconsistent mode. And the one that has maybe updated, and the one that has deleted, the one that has probably inserted, and all those things will be managed in such a way that eventually the database will still exist in the consistent mode. So as we get to that end, you will see how the mechanism works to handle all of them, that we will not have a problem. Okay. Any other question? Okay, so let us move on to the next section. So this concept that we are talking about is what has been described here. It's generally common. The concurrency is normally common when we are in the multi-user environment. In actual fact, if it's not for the fact that we want several people to have access to the same data object at the same time, this concurrency control will not be necessary. For instance, if we have a situation where a user would have maybe hold a data item, finish all the work he wants to do with it, and leave it for the next person, the next user to hold it, do whatever, then leave it, and then so forth, so that we wouldn't have this problem of even have to control any concurrent. All we need to do is to ensure that one user finishes working with the object before the next user takes it. But if we leave it that way too, there will be a problem. What do you think will be the problem if we go by one user completes work before the next user and then so forth? What do you think would be the problem? Anybody can suggest what might be the issue? Or what do you foresee if you want to, if
Okay,
in
hello.
an environment?
Hello.
Yes, Erasmus.
Okay, Prof.
Mhm.
If one person supposed to work it and the second will take over, first of all, we will have inefficiency in the work. At the second point will be
we will have what? We will have what?
Inefficiency in the work.
Inefficiency.
Yes.
Okay.
I can explain if you want.
Explain.
The inefficiency that I'm talking about will be in the delay by producing some work at a time.
Okay. I think
But
you have answered. Oh, you want to continue? Okay, that's the point 2.
Yes. The point 2 would be the point 2 would be no, it's almost the same thing I wanted to talk about.
Almost. Okay, that's right.
Yeah, it's almost the same thing. I wanted to talk about the delay, but it's almost the same thing.
It's almost the same. Okay. Thank you very much for the answer provided. Any other person?
Yes, sir.
Okay. All right.
Yes,
Simon.
so okay.
Hello.
Go ahead.
Okay, thank you. Since one person would have updated it, then they might have updated it, then the next person has to recheck and find the value that is now the updated one before he can work with it, which will cause unnecessary delays.
Okay. So you are also talking about delay. Actually, because they are now doing it one by one, the first person works with it, maybe does the update before even the next person will go and read. So that the second person wouldn't have even read anything at that stage because it might be waiting for the first one to finish. So invariably, it boils down to the same delay. So I would take I think, is there any other hand up? I think that's it. Isaac should respond and we'll move on.
Yes, Prof. So could we also say it might cause coordination issues where, let's say, 3-4 people finish at the same or are ready at the same time to use the database? Who gets to go first? Then it means there's going to be a coordination problem that must be also solved. That, okay, since you all finish at the same time, you go first, second, and third. That will also be an issue that can cause trouble.
Okay, so that coordination or maybe some kind of queue, having to say who should go first or who has priority and so forth will also be a problem. And eventually that also amount to delay. Okay, well, I'll give chance to the last person, George. I think George's hand is up, but it appears it's not ready. Okay. Then we can continue. So if you want the better throughput, better execution time, transactions should interleave. Interleave means that maybe 2 statements are executed here for one user, it goes to execute some for the other user, it goes to execute some for the other user, comes back to the first user. So the transactions should interleave. So if it does it that way, would the performance is better than to leave it for one person to finish, one user to finish, and before the next one. So so transactions should interleave, but that transactions interleaving also now begin to create problems for us. Also begins to create problems for us. So we are coming to look at the fact that transactions should interleave to improve performance of the system. And when we come also to parallel processing, which maybe we will discuss next week, you will also see that when transactions now begin to interleave, then the performance is far higher. So far as concurrency controls and others are in place, transactions should interleave so that if 100 users 100 users are trying to access the same data object at the same time, you should allow all of them, so to speak, until we put in all the necessary controls that all of them can access it, but some can be doing something whilst another cannot do something to it. For instance, if all of them are coming to access the object, we should allow all of them to access the object, because that one wouldn't create any problem. So far as nobody is doing any update to it, all of them just want to take a look. They should all be able to take a look. We can also put other mechanisms that will be seen in concurrency control protocols, where one can be writing at the same time, somebody can be doing something, and then they will share the transaction, be interleaving all right, but they would have a mechanism that would deal with it in such a manner at the end of the day. Transactions will not, items will not be thrown into inconsistent mode. So transactions should interleave to improve performance and even throughput. But these are some of the issues that will come with the concept of the fact that transactions should interleave. If they also interleave with that proper concurrency controls, we'll have these issues, a number of issues, but 3 of them are listed here. One is lost update problem. Another one is uncommitted dependency problem. The other one is inconsistent analysis problem. So these are some of the problems that will crop up if transactions interleave without concurrency controls. Okay, so let's understand by these examples over here. So we'll take the first one, the lost update problem. The lost update problem. Let's take these 2 users, the T1 and T2. This is transaction 1, transaction 2, being performed by 2 different users, maybe from 2 different terminals, 2 different machines. So first we have the T1. We have T1, the timings are here, T1 down to T6. So at time T1, transaction 2 starts by saying begin trans. Okay. What we are doing here is that as one transaction is deducting some value from a balance, another one is adding a value to the same balance. So you will see that at T2 transaction, T1 reads a balance X, and that balance was actually 100 Ghana cedis. So it reads 100 Ghana cedis from disk. So the next step, you see that the transaction T1 or user 1 also reads the same balance. So at that point, it will also have read the same 100 Ghana cedis. Now, at that point, the user 2 adds 100 cedis to what it has read. So what it has read initially was 100, so it has added 100 to it. But when you see the line here, you see that only 100 is still showing here. The reason is that it has not yet committed, and this is just merely non-database operation, these values being held in memory, merely in memory. That's why you don't see on that line, you don't see that the balance becomes 200. No, it has not yet become 200. It's just in memory that is holding the 200. Okay. So when we come to the first user is also deducting 10 from the 100 it has read. If you are not careful, you may think that because this one has added 100 to the 100, the balance should have been 200. But because it has not written it to disk, this transaction, the 100 that it's holding is the 100 that it knows. So it will also go and deduct 10. At this point, the user 1 will be holding 90 CDs. So now at this point, in memory, user 2 will be holding 200. User 2 just continues to write the 200 to disk. So the balance is 200 to disk straight away, which is correct. Because at that time, the user 1 has not yet written. Just after that, at time 5, the user 1 now has written his 90 CDs to disk and commit it. So it will just go and overwrite the transaction. The user 2's 200 that has been saved is now being overwritten by the user 1, and then it becomes 90. So that is a big problem. So you see that this is really a big problem. The update that the user 2 has made has been lost, overwritten by what transaction or user 1 has done. So we call this kind of situation the lost update problem. I'm sure you all understand what I've just described. If you need any further explanation, maybe I can still provide some explanation. You see that is a big problem now. If ordinarily, assuming that everything works out well, and these two transactions execute to the completion, what do you think will have been the final balance? If one deducts 10, another one at 200. If things work out well, what will have been the correct balance here? Anybody?
190.
Yeah, it should be 190. It should be 190. But it now becomes 90, which is completely wrong. Completely wrong. Now, for the sake of just trying to see whether you can think through what should be done, what do you think, in your view, should be done such that this situation doesn't occur, that it will eventually give us a 190? Or do you think two users running their own transactions? And then we said that the isolation means that one should not know about what the other is doing. And of course, that's what happens here. This one has no knowledge about what the other person is doing. What do you think, in your view, assuming you want to provide a solution to a problem like this, do you think should be done? I'm not asking because you know, but when you look at it, okay, Prince.
Prof, I'm looking at what on this.
We can't hear you.
Your line is very faint.
Please, can you hear me now?
Uh-huh.
Yeah, so I was saying that from what I see on the screen, a solution that I see is that we should have some form of locking mechanism so that when one user performs a transaction on a record, then we kind of maybe lock it for some time for that transaction to finish before the other transaction also continues.
So how do you relate it to what we are seeing on the screen? Can you explain it using what we are seeing on the screen?
So we are seeing that the two of them
Okay, as you are deliberating, maybe another person can also help. Erasmus.
Yes, Prof. I think here we're supposed to apply the property of the concurrency.
Property of?
The concurrency property.
So how would it be applied here so that it will give us a 190 eventually?
Okay, let me look at the thing very well. I'll come back.
Okay, you know that there should be concurrency, some kind of strategy to do it. Okay, but as to how, okay, so I will not provide answers now,
Prof,
but there should be concurrency.
what?
Okay. The line is not very clear.
Prof. Prof.
Yes.
Please, should we also be looking at the atomicity?
The atomicity is already working. That is the reason atomicity. The atomicity that all or nothing. The all or nothing event.
Yeah.
How could that apply here? Because atomicity is saying that a set of transactions should be regarded as atomic, as a single statement, kind of. So all these are why we have begin and commit. So every statement here, 3 statements inside here are now atomic. The begin and commit here, the 3 statements here are also atomic. So it is all or nothing. But here all of them execute to the end successfully and they committed. There is no error for it to reverse everything to nothing. All of them did it to the end and they all committed. But then the problem is, one, the value from one program or transaction overrides the value that was obtained in the other transaction. That's where the problem has come.
So, Prof, we can lock one for one transaction to complete before we start the other one.
So, with the examples, what we are seeing on this, which one do you lock for which one to complete before the other?
So we can lock T2 first, and then we start the T1. Then now when it is done, then we unlock the T2.
Okay. Okay. There are a number of.
Prof,
we can.
Instead
okay,
of
go ahead.
Instead of maybe locking the transaction like my brother said, we can check if the data has been modified before committing the next transaction. So in the case where we are trying to do a -10, we check if that data has been modified previously, and if it has, we don't actually we don't commit, but we put that -10 in a lock state and allow the previous to run, and when it's done, we come back to do the -10 from T1.
Okay. So in your, I'm sure you are a programmer. Do you write computer program?
Yes, please.
The way you explained that thing, it sounds like you are a programmer. So what happened? You are suggesting that even though it reads the value, both of them read 100. When this user 1 is about to maybe add this to this, it will go and cross check whether the value that it read first is the same value that has been there. Then if it is the same value, it continues. What if it is not the same value? It reads the current value of the data before it does a subtraction, something like that sort. Is that not it?
Correct.
Okay, all right. Now I'm listening to all of you. Okay, Al Hassan.
Good evening. Actually,
Good
for me,
evening.
I will go by the locking. Looking at
You go
the
with that.
yeah, looking at the what is displayed. T2 started the transaction first. So basically, from programmer's point of view, if you are going to edit the transaction, when you retrieve the data, you lock it until the transaction is committed or it's aborted before you release it. You release that particular record.
Okay. Okay. So actually, the locking protocols we'll be dealing with that. But I just want to throw a little bit of challenge for you to think through and see
I will finish on now.
what can be done. Okay, so let's move to let's leave this. We will be coming to solutions as to how this could be done using the locking protocols later on. So let's look at the next problem that can occur. So let's see this example. We call this one the uncommitted dependency problem or dirty read. It means that one transaction actually reads some data, but what it has read is dirty. So let's look at this and then begin to figure out what has happened here. So transaction, the user 4 reads a data, add 100 to it, and then write it. And when it writes it, it's having 200. Okay, then transaction user 3 reads the 200, all right, and subtracts 10 from it. So it does a subtraction 10 from it, and is holding it in memory. Now it will become 190. It goes to write the 190 to disk. But at the point where this transaction has written this, there was an error that has occurred. So it has rolled back all that it has done earlier. Maybe an error has occurred somewhere. So when it roll it back, it will come back to its original state of 100 that it has read from the beginning. So to this transaction, the value should have been 100 because it has rolled back everything. But to this transaction went ahead and then wrote what? 190 to this. So you will see that the two users are now having two different values, or so to speak, because this one should be holding 100 because I hold back everything. So you begin to realize that what this user 3 here read becomes dirty. Becomes dirty because it read 200. Meanwhile, the value as it should be now should have been 100. So it read 200 because of this right. It read 200. And so we call this kind of situation dirty read. Okay. Because of the fact that this rollback is transaction to original state of 100. Meanwhile, transaction 3 has already read that value, wrong value of 200 before this one rollback. So that kind of scenario is referred to as dirty read. So let's take the next example. The next example has to do with inconsistent analysis problem. Maybe as one user is doing some reporting or analyzing the data. Another person is updating it. Most of the time when we are analyzing or generating reports or analyzing data, most of the statements that we put in there are barely read statements. We may read and aggregate and provide subtotals and summarizing data and so forth. They are generally read. Because at that stage, we don't write and update when we are doing reporting or analyzing contents of data values in tables. So as one transaction is basically summarizing the data, maybe for reporting purposes. At the same time, when that transaction fetches values to memory, and as I told you before, values fetched to memory, we can do non-database operations of them by summing and all that on it. At the background, another user is updating the values in the database. So if we have already read values to memory and we are analyzing them on disk, and then we write computer programs to be adding some of the data objects that have been read to memory, the values that will be seen will differ from the ones that somebody at the background or another user somewhere is now updating the values. So the values we have read will be different from the current updated values written to disk. So this kind of situation, we call it inconsistent analysis problem. In your view, what do you think? Maybe I will leave that one. I wanted to find out, how do you think this kind of thing can be sorted out? Assuming that you are not using locking protocols, but then maybe somehow you still feel that even though I don't use any locking protocols, how should my report reflect? How could they reflect the current values that the transaction T or user T has performed on the database? Anybody's view? Yes, Hassan.
I think you use notification. You notify the user.
You do what?
Notification.
You will do what? You would
notify the user. Use notification. If the value has changed, use notification.
That will be a problem. The database will automatically notify the user that there has been a change in the data items in the table.
Yeah.
That will probably create more problems. So then the number of notifications we'll receive will be plenty. Because if, for instance, 100 users are holding that table and they are performing things, the updates on this at the background, so notifications coming to the user that there have been changes in the database might be plenty, can even cause inconvenience. Any other person's view? You've done well. That notification could help the user to know and then maybe take appropriate action anyway. But just that its operationalization would create inconvenience. Any other person can suggest what could be done?
So maybe we could
there should be.
I was saying that we could isolate the transactions, so that, let's say, as one is happening, they could be concurrent, but like maybe serialized. So one should happen before the other, probably, and that could help avoid the inconsistent read.
Okay, but when changes actually happen at the background at the time, let's bring this a bit practical. Let's say you generate a report And as the report is on the screen, let's say it's a balance sheet, and it's showing on your screen with the values, asset value, liability values, and all this on the screen. Somebody went and changed one of the plans. Maybe you have calculated depreciation on it and the balance has decreased. But the report is now on the screen that you are seeing. That screen wouldn't have known about what has happened to the data item at the background because the value has changed, probably decreased or something. And then that report is on your screen. And I'm asking, simple. Now, what do you think can be done such that that current value will reflect on your report? Okay, Samuel.
How about using data streams or WebSockets or something like that?
Okay, so that would handle some aspect of you. Let me just bring your mind to when you visit a number of websites, a website which is database driven, like let's say stock, financial stock management. You know, stock prices are changing so fast. What do you think one will need to do such that when you are on the screen and you are trying to make a decision on some investment and the values change at the background, what do you think that website or that screen should do so that current value would be displayed rather than the previous one that you pull out first? Or what mechanisms are used to let it reflect the current balance? You people, you've been developing web applications, you don't know this.
Refresh and
real-time
extract them.
communication.
Yeah, just be refreshing within certain time, very
Yeah.
time intervals. The transaction will run again, so it will give you current values. So it will just refresh. Once you refresh, you automatically refresh, and then you will see that the current values will show. That's by the way, but that's not the transaction we are talking. Locking protocols we are going to talk about. But I'm just bringing your mind to the fact that one can use facilities like refresh, simple code, and then the screen will refresh at any time interval that you have set. Okay, Erasmus. There is a hand up. Oh, you've said what you wanted to say.
Yeah, Prof, usually for the reporting purpose, when we are doing the reporting, we always we download the data that we wanted to reporting before, even if you have any changes after that's affected the downloading, because we always have the day or the time that we wanted to do the reporting. So at that time we download the data, and from this data that we do the reporting. Any changes will come later will not affect your download or your actual data that we are using to do your analysis.
That is most of the time when normally if the situation like I want to see a certain report as at maybe yesterday evening. If I am looking at the report as at a certain point in time, you download it and then you put your report on the file downloaded so that current changes to the database is not your problem anymore. But if assuming that is a stock exchange and people are taking decisions based on the current value, and then you are looking at a report that was generated yesterday evening, meanwhile things have changed behind the scene throughout the day or something. In situations like that, you will need to see the current stock prices rather than what has happened downloaded yesterday. So in real time scenarios, we will prefer to rather refresh so that we can see what is it exactly now. So both what you have described is correct in many scenarios, like many of the operations we perform in offices. But there are also scenarios where we want to look at the very real-time figures of certain reports. Okay. Now, in order to, yeah, there are so many other problems that can happen. You can read about others as well, but at least we demonstrated 3 of the problems that would occur when we want to also go by serialization. Sorry, we want to let the, what do we call it, the transactions to interleave. These are some of the problems, but transactions must interleave, and concurrency control should be able to take care of them. Okay. Having said that, let's take 5 minutes break so that we'll come back 8:40, and we will have 20 minutes to continue. I want to stand up and stretch my legs a bit. We'll come back to continue after 5 minutes. 20 minutes we'll be able to do a lot. Okay.
Gosh.
Okay. All right. So we are now moving to gradually to how to deal with the problem. The problems that we have just described, we are now coming to start discussing how to solve these problems. I trust that you can hear me and also view the screen I'm sharing with you. Can you hear me loud and clear?
Yes, Prof.
Okay. Okay. So now we come to the concurrency control protocols. So the objective of concurrency control protocols, one of them is to schedule transactions in such a way as to avoid any interference between the transactions and hence help prevent the types of problems we have described. The very obvious solution that we've talked about earlier was that we allow one transaction to execute at a time until one transaction committed. Then the next transaction also begins and committed, but we realize that that would be a problem in terms of performance. So that situation will not help. We would prefer transactions to execute still concurrently, but without interfering with one another. So the concept or some of the concepts that we will talk about that will lead us to the solution are here. One of them is what we call schedule. Schedule, which means a sequence of operations. A sequence of operations by a set of concurrent transactions that preserves the order of the operations in each of the individual transactions. Okay, we can, to some extent, schedule transactions in such a manner that even though they interleave, this sequence of operations, even though they interleave, we can preserve a certain order and then preserve them in such a manner that they will not interfere with each other. We'll be talking more about schedule when we move on. And this can actually be done by what we call serial schedule. There are two kinds of schedules. We have serial and non-serial. So let's see the serial schedule. Of course, the name of something is in the name, the meaning of something is in the name itself. Serial schedule. The schedule where the operations of each transaction are executed consecutively without any interleaved operations from other transactions. Then non-serial is a non-serial is a schedule where the operations from a set of concurrent operations are interleaved. Okay, so let's read the objective. The objective of serializability is to find non-serial schedules that allow transactions to execute concurrently without interfering with one another and thereby reduce a database state that could produce serial execution. So let us see how serialization could order transactions in such a manner that they could interleave. So in serializability, the order of read and write operations are important. One, if two transactions only read a data item, they do not conflict, and order is not important. So when we are doing serialization, and we notice that even segments of some transactions or reading data item, there is no way they would conflict because they are just only reading. So in that case, they will not conflict, and order is not input. It doesn't matter whether user A reads first or user 2 reads the data first. Whichever reads the data first, they will all eventually read the same content. Okay. So if they are doing reading, we don't have any problem. 2, if 2 transactions either read or write completely separate data item, they do not conflict, and the order is not important. So if they are 2 users are reading or even writing, but they are doing it on a different data items. Let's say the 2 transactions are accessing different tables for data items in different tables. We don't really bother about this. They will definitely, serialization or conflict may not occur because they will not conflict at all. But if one transaction writes a data item and another either reads or writes the same data item, the order of execution becomes important. So when we are doing serialization, we should look at this, that if they are all reading the same data item, even the reading and the writing are important. Otherwise, one may write and another will go and read maybe dirty data or whatever. So the key issue now, or the key worry now, is about the transactions that are writing or reading the same data item, and therefore the order of the execution should be stated clearly. Okay, but even with the order alone, even with the order, we will need to bring in some control that we'll be talking about probably next week when we meet. We can finish that quickly and move to a new topic. Now, there should be a control that would have to be applied to the reads and then the writes in such a manner that there will not be any conflict. Okay, so that you can read about all these non-conflict serialization example, that if there is a serialization in this way, there will not be any conflict. Of course, if maybe we can look at this transaction 9 and transaction 10. That transaction 9 reads add write. Then the transaction 10 now goes to read, perform some operation, write, read, this, and so forth. Then it writes balance y. Now transaction this comes to read the balance y, and then you continue to deduct, and so this one will not conflict in any way. Will not conflict in it. All of them will get the final answers correct, because the reading this one writes before this begins to read the current value, and then it writes before this also begins to read the y, and so forth. So this example of non-conflict serialization schedule. Okay. You can read about all this, that will give you better understanding of what we are discussing. Then we could look at how we handle what do we call it, the protocols. I want us to jump straight to the protocols. Okay. Maybe we should end it here today, so that when we
Yes,
meet
yes.
next week, you agree with me that we should end it here?
Yes.
Okay, so when we meet next week, oh, okay, yes, when we meet next week, Tuesday, but I'll meet the Saturday group on Saturday. When we meet next week, we will use some 30 minutes to deal with the how do we call it, the protocols, that the control protocols that actually help us to carry out concurrent execution. Then we can start the parallel databases or parallelism, which also relates with concurrent execution. So on this note, we will end it here today, but I'll allow for questions. If you have some questions or comments or suggestions to make to improve the class, or anything you want to talk about, I can still accept few. Okay, Michael.
Okay, Prof.